Hello, welcome to lesson 3 of our section 2. This is more lab safety and get into more details so that we can be safe instead of sorry. So, to really have the kind of safety we're talking about, we need to know all the types of risks. We can't identify the dangers like we talked about before unless we know what kind of risks we can be dealing with. We need to recognize what risks we're currently confronting with whatever we're looking at, and we need to minimize the chance of those risks. So here's a cute little lab safety poster I found that listed a bunch of different kind of hazards, some of which we definitely don't have to worry about in our room. So types of risk to people and property, right? Because the things that can be harmed are people, which is very important. We try to avoid that for the whole year if we can. And then property, like, shirts, shoes, textbooks, backpacks, walls, tables, etc. So sharps, that's cutting or puncturing, like scissors, razor blades, pretty straightforward. Crushing is from large or heavy objects. If you dropped a textbook on your foot, that'd be a crushing risk. If you dropped a metal weight on your on the table or something and dented it, that's part of it being a crushing risk. Breakage is fragile objects that easily break. Burns are caustic. That's a fancy word for a chemical that will damage your skin or damage a book or something, even though it's not warm in the regular sense, but hot things cause burns as well. And then there's irritants. So, like if you've been around a fire at like the beach and like it started making you cough and your eyes water, that's an irritant. And lots of chemicals in a lab can be irritants to the eyes, nose, throat, and skin. All right, so let's talk about each of these in a little more detail. For sharps, object has sharp edges that may cut. This should not be news to you. Object that could break and when broken have sharp edges. Glass often has this issue where broken glass is a sharps risk, a very dangerous sharps risk in the sense that it's very hard to handle glass that's broken without cutting yourself. So how risky? Sharps are never, ever generally safe. Anything that has a sharp edge is at least low risk, right? Because even doing everything correct, there's always a chance that something could get cut, right? Now, scissors are low risk. The edges are usually covered. It's using them properly. It's very safe. It's very unlikely that you'll cut anything you're not intending to when you use them properly. Like I said before, glassware is very high risk when it's broken. Now, crushing. That's an object that's dense or heavy for its size. Brackets, metal weights. Your water bottle, right? Something that's really big, like one of my ramps. Now, how risky are these things? They're generally safe to low risk, right? A textbook is safe. If you have to make a silly mistake, you have to be goofing around and lose it or knock it off a table before it could hurt somebody. Okay, so make sure you're always carrying such things properly. Okay? A dense object, like a piece of metal that's really heavy, like one of our weights, those are low risk because they can easily cause harm if something happens. Make sure you always carry them carefully and keep them away from any edges. Breakage is fragile objects. I mean, these get used in a manner that they can break, or they're just easily broken. So some things that are used in a manner that they can break might be a thermometer. If you're not careful with it while you're using it normally, it can easily break because they're very fragile. Now, when it comes to how risky, these objects are generally safe unless broken. A test tube, a glass jar, a thermometer, unless you break them, they're not going to hurt you, right? At least on their own. Glassware tends to be reasonably durable as long as you don't drop them or hit them with something, right? We use glass not because it's so fragile that if anything happens, it instantly breaks, but you need to be careful that you don't cause it to break. Now, cards and other complex tools that you could potentially break, like say a scale, they tend to stay safe even when broken. It's hard to unless you're really trying to destroy it, it's hard to break it in a way that causes it to be more dangerous. Now, we're talking about burns. Try to ignore the bottom. Chemical burns come from caustic chemicals. The chemical itself, like an acid, irritates your skin or burns your skin if it's really strong just from touching it. Thermal burns are from hot objects or fire. I'm pretty sure you're aware of the idea that a hot thing can hurt you. Now, anything that causes a burn is always high risk. You need to be using protection just because if anything happens, you can easily get hurt, and we don't want that to happen. Okay. Now, we don't use any corrosives in our lab, at least that you get to have access to, but there's plenty of acids that are strong irritants, which means if it gets on your skin, then it's going to cause pain and need to be washed off fast. It doesn't cause lingering pain. And if it got into your eye, it could cause like a serious burn that would be pretty problematic. And chemical reactions can cause enough heat to burn your hand if you hold them unprotected. Never, ever hold glassware, hold a jar, hold a test tube that is currently undergoing a reaction, because you do not know for sure if that is a warm reaction. And if it's going to get warmer, it could get very hot, and you could not just burn your hand, but then you let go of the glass, it could break, and whatever is inside that glass will spread all over the table. And this is a lot of bad things at once. Never ever hold glassware while it's reacting, while there's a reaction inside it. Next one, irritants. Now, objects that on contact cause irritation, like rashes. I talked about this a little bit in the previous one. It could also be your skin, eyes, nose, or lungs, or throat. Now, how risky? Until otherwise, all powders should be treated as low risk. We don't have anything powder that's like super dangerous, but a powder can easily go up into the air and get what's called aerosolized and be floating around. And if a powder of some metal or something gets in your eye or or you breathe it in, then it could cause irritation and not be very, very pleasant. So whenever we're transferring or pouring powder, be very careful to not like toss it around on accident or trip and throw it or something. And if there's any smoke in the room, we shouldn't have much in the way of smoke, but if there is any, try not to breathe it in. And don't smell chemicals directly. Don't go, because it could be something that really makes you feel bad when you do that. All right, now let's talk about how we can prevent accidents and harm in general in this room. We have to always carry objects with care, right? Maybe if you're carrying like a ruler and some other like general normal classroom supplies, you might be a little more cavalier, unserious. But anything that we use in labs, you have to always carry it with care, because dropping it is one of the primary ways these things can be dangerous or cause harm. Glassware should always be in a holder, which you'll learn about later, or on the table directly while you're using it, if it's the flat bottom kind that can support its own weight. All chemicals should be treated as low risk, period. T. No chemical is generally safe. And some of them, like acids, are high risk, which I'll point out to you when those chemicals are around. All lab materials and tools should be at least 2 inches from the edge of the table. 2 inches, like maybe the length of a finger, one of your short fingers, right? It should be at least that far, if not more like one of your bigger fingers from the edge of the table, unless there's a lab protocol that has it going to the edge, which happens sometimes, mostly in physics. And never stack materials on top of each other in an uneven stack that might topple, right? If you put like something like a textbook at the bottom and put some things on top of it that are all flat and they go from biggest to smallest, and it's a small stack, that's fine. But don't be stacking stacking glass on a textbook and trying to carry it, because that may fall over and cause a big problem. Now, here is our digital practice assignment. You're going to gather the following materials. If I haven't set them out because you're ahead or behind, let me know and I'll bring them out. You're going to put them on your table carefully and organize them from least risky to most risky. So pick a direction. Maybe on the left side is the least risky thing, the thing that is the hardest to be dangerous, and all the way to the right, the thing that is easiest to be dangerous. And then use a piece of paper, an index card, or several, and label the risks, if there's any you can think of each object. The risks that we have listed here are sharps, crushing, breakage, burn, irritant. Does this object do one or more of these things potentially? And here's a list of objects. A ramp, those are by the middle cabinet, and a weight set should be on the table. Scissors and ruler is over on the supply side. I'll be putting out glass beakers on the supply side. There's a jar that will be labeled, there should be jars labeled acid. There's only a little bit of water in them. It will specifically say acid quotation marks because it's not really acid, so don't be afraid of it. And once you've finished doing this activity, put all the objects back. And I'll remind you again, be very careful. Do not break any of the glassware. Be very careful carrying these things. Okay, this is our first time working within these objects directly, and let's start strong and not have a problem. Good luck.